Yes, definitely.
Okay.
Thank you to suggest me. I'm definitely discuss and I will share my notes also. So already discussed about the normal distribution. Yes, friends. So please remember the definition, formula, properties, methods, and the graph of the normal distribution, which will be helpful to solve the example. So without wasting the time, we'll go fast. So already we have discussed this. Once again, I will discuss normal distribution. So properties we have. Properties of normal distribution, students. It is a normal distribution where it is a distribution with continuous probability distribution for a random variable. A very important continuous probability distribution in statistics. Yes, this is very important distribution for your internal as well as for final exam. And most of the questions will be from normal distribution. The graph of the normal distribution is a normal curve. So you can see this curve. This is what we have, a bell-shaped curve is a normal distribution. So here you can see the method of probability calculation for normal distribution is, if you take the probability that a continuous random variable x lies between a lower limit a and an upper limit b, then you will get the probability p of a is less than x less than b, which is equal to area to the left of b. So you can see through the graph, you can see area left of b minus area left of a, which is equal to probability x is less than b and minus probability x less than a. So you can see in the graph, I want to find the area from a to b, which is equal to, I can take this as infinity to b minus infinity to a. So in between I get the area a to b. So I'm going to remember in the normal distribution, we will define a variate that is going to have the z is equal to x minus mu divided by sigma, where mu is nothing but mean and sigma is nothing but standard deviation. So you can see in the normal distribution, very limiting values we have calculated. For large number of values, suppose the n, I think you remember from the binomial distribution, n is nothing but the number of trials. If this n increases or it will become large value, then we have to go for normal distribution where it is useful. Normal distribution is useful for large value of n students. You can see this is of the form normal curve will give you y is equal to 1 divided by sigma square root 2 pi into e raised to minus x minus sigma the whole square divided by 2 sigma square, where mu is mean and sigma is standard deviation. You can see this is a bell-shaped normal distribution, and you can see this x is equal to mean, that is a symmetric on LHS and RHS. Symmetric means what, student? It is symmetric means LHS and RHS will be equal, where you can see the full minus infinity to infinity, you are going to take the area will become 1 and LHS will become, area will become 0.5 and RHS it is going to get, you are going to get the area 0.5. That is the standard normal distribution. So this is distributed area. So now you can see the probability of x lying between x1 and x2 is given by the area under the normal curve. So if you take any area between these two lines x1 and x2, then we take the probability x1 is less than equal to x is less than equal to x2, which is equal to 1 divided by sigma square root 2 pi integration x1 to x2 e raised to minus x minus sigma minus mu square divided by 2 sigma square dx, friends. Please remember this formula. So when you convert this normal distribution to standard normal distribution, we are going to go for the standard normal distribution variate z is equal to x minus mu divided by sigma, where we can see probability of z lies between z1 and z2 is given by the area under the normal curve from z1 to z2, which is equal to your probability z1 is less than equal to z is less than equal to z2, which is equal to 1 divided by square root 2 pi integration z1 to z2 e raised to minus z square divided by 2 dz. So this is our standard normal distribution, what I have told you. In the standard normal distribution, mean we have to take here 0 and full area will remain 1. Remember this, from minus infinity to infinity, any area, any curve between this, you are going to get take area is equal to 1, and your standard variate we are going to get this as z. You are going to convert the normal distribution to standard normal distribution. Z is equal to x minus mu divided by sigma. Please remember this. So properties already we have discussed. Once again, I will just share here this views. The cumulative area for z is equal to 0 is, you have to remember, 0.5, and cumulative area full area will be closed to 1. Then suppose if it is closed to 1, then where this curved line meets that point, I'm going to take this at z is equal to 3.49. So what you have to remember here, student, very very important, the first point, probability area between a is less than x less than b. This area you are to going to remember. And for standard normal variation, that is variate, you are going to change the values from x variable to the z is equal to x minus mu divided by sigma. Please remember this formula, and this is how we are going to calculate by using the curve. I will go to the example, very very important. Please write down this example. So please be ready with the calculator. I'm going to show you the shortcut how to use the calculator, and once again you can go through this video when I upload this video. Yes, student, please be ready now. So first question for normal distribution, very very important. It is evaluate the following probability with p of z greater than equal to 0.85, and second, third, and fourth we are going to calculate. So one by one we are going to simplify this example. Please be ready. So what we have here, student, solution. And first we are going to calculate the value, that is probability of z greater than equal to 0.8. See, upper limit they have not given here, means infinity. You are going to consider this infinity. Please remember this. So I'm going to take here the probability area from 0 to infinity. First I will take the larger value minus probability area from 0 to 0.85, student. That will be the smaller range. Means I'm going to take b, a larger length, subtract the small length. Definitely you will get the area z less than greater than equal to 0.85, student. So this is what I'm going to take the probability. Then you can see probability of area from 0 to infinity. As I have told you, it is half of the area, that is 0.5. You have to remember. Please remember, area from 0 to infinity is 0.5, as well as area probability of area from 0 to minus infinity is also 0.5, student. Now I will take minus probability area from 0 to 0.85. I'm going to take this function as phi of 0.85, friends, and you can see from this graph it is easy to understand. So I'm going to take this as a normal distribution graph, that is bell shape from minus infinity to 0. The length between minus infinity to 0, already told you the area you are going to consider 0.5, and I will fix one point, that is 0.85. I will fix this, and greater than this, that is infinity, you are going to calculate. This is what you are going to calculate the area, student. So before calculating this area, you are going to divide this full area will be 1. Remember, minus infinity to infinity in normal distribution you are going to take 1, and half of that, 0 to infinity, 0 to plus infinity, 0 to minus infinity will become 0.5. Directly you have to remember this. So you're going to calculate the area from 0.85 to infinity. So I have divided this. I will first take from 0 to infinity, subtract the area from 0 to 0.85, student. I think this is clear. So please be ready with your calculator now. I will show you how you are going to calculate phi of 0.85. This function is already fixed in your calculator. So please be ready with your calculator. I will show you the shortcut how to calculate the standard normal distribution. That is the function phi of 0.85. First, on the calculator, go to the mode. You can see in the mode there is statics. Yes, 3. Press number 3 button. Static. You can see number of statistics, but we don't want, just press AC. So it will, you can see, press AC in the calculator. At the top you can see there is statistics. Then go to shift 1. 1 you can see above they have given statics. So you can see it is 1, shift 1. So I will repeat once again. First press on, then go to mode. After mode, you will see there is a static. Press static button, that is 3. Then go to AC. Then in the calculator you can see at the top statics. Then go to shift 1. You can see this 6 values. In this we are going interested in the distribution, therefore press 5. You can see 1 2 3 4. In the second one there is the standard normal distribution values are stored, so press 2. You can see that is the Q. So Q, you are going to substitute the values here, that is 0.85. So already the values are stored in all the calculators of 99 ES, sorry. So you can see when you
Sir, once again.
go through the value 0.85, you are going to get 0.30234 students. It is very simple. Please be ready with your calculator. Once again I will repeat this. First press on, then go to mode. After mode you can see there is static number 3. Press number 3. You can see different statics are there, but we are not interested in this static, therefore press AC. Then till here you have done? Yes, please unmute and tell me. Till here you have understood?
Yes,
Okay.
sir.
Okay, please now go to shift. Press 1. Shift 1 means you can see statistics 6. You are going to get 6 values you are going to get. We are interested in distribution, that is number 5. Press number 5. Then you can see 1 2 3 4. So now standard normal distribution values are stored in number 2, that is Q. So I'll repeat once again. Press on, then press mode, go to static number 3, press 3, then go to AC, press AC, then go to shift, press shift, then go to 1, press 1, then go to 2, press 2. So I think your Q will appear, then you have to type only 0.85. See, student, this is a very shortcut method. So you can press 0.85. You're going to get the value. I think everyone got the value 0.3032 like this. Substitute the value, student. So start solving the example. 0.5 minus 0.3023. If you subtract the values, you are going to get 0.1977, students. So that is the probability of Z greater than equal to 0.85, students. So practice this example again and again. It will be very easy. Immediately we'll go to the second one, that is probability between minus 1.64 is less than equal to Z is less than equal to minus 0.88. So minus means it is in the left side of the curve. So you can see this is the area I'm going to calculate from minus 1.64 to minus 0.88. Please remember this area. So to calculate this area, I will take the larger length now, that is 0 to 1.64 I will take, and I will subtract this with 0 to 0.85. So I'm going to take the probability area from 0 to 1.64 minus probability area from 0 to 0.88. So this is what you are going to calculate. Means I'm going to calculate the phi of 1.64 you are going to calculate minus phi of 0.88. This is the value you are going to calculate from the calculator, student. So again use the calculator and please see, check the answer once again. Please yourself try it. Those who have not understood, I will show you. So you can see the graphically how this you can show this graph. So that is, take the normal distribution curve, bell-shaped curve, take the mean as 0, and this will be from minus infinity to infinity. As this is in a minus sign, therefore it is left side. So I'll fix minus 0.88 point, and I will fix another point, that is minus 1.64. I want the area between this. So what I will do? I will take area from 0 to 1.64, subtract the area from 0.0 to 0.88. That is what I have done. So again, use the calculator, student. Here you can see I will go through again on the calculator, then go to mode. I'll repeat this once again. Go to mode, then press 3. You will see there is a statistics. Press AC, then press shift 1. Shift 1 you press. You can see there is a distribution 5, button 5. Then go to Q, that is 2. Then you can see there is a standard normal distribution values are stored. Just press the values. So it is 1.64. I think everyone have got 0.4495, I think. So you can write down 0.4495 minus, you can don't change the settings of the calculator, just put 0.88, substitute the values. I think everybody have got 0.31057. You can round off this, taking the 4 values, that is 0.3106 you can write. So I will also make the same correction. I will round off to 4 values. So subtract this value, student, you will get 0.1389 students. I think everyone got the same answer. Yes. So immediately we'll go with the next one, that is the third point. Everyone you to calculate. Yes, please tell me what is your question.
So why we need to select only Q in the calculator?
Already I have told you. Once again, I will tell you that the standard normal distribution values are stored. Standard values are stored in the Q. Is it clear?
Yes, sir. And sir, those P, Q, and T, what for the use?
They are with different distributions. Okay, that we are not interested. So to find the area, yes. Okay. So next, that is the probability of z is less than equal to minus 2.43. That is what you are going to calculate. See, lower value will be minus infinity. So you are going to calculate the area from minus infinity to minus 2.43. This what it means. That is the z is less than equal to minus 2.48. So means that you are going to take area from 0 to minus infinity or minus infinity to 0. Then subtract this area from 0 to minus 2.43. Then you will get the area from minus infinity to minus 2.43 students. Okay, always take the 0. Graphically, you can see the normal distribution curve, that is a bell shape curve. You can fix, I will fix the value here, that is minus 2.43, that is in the left side. This area you have wanted to calculate, please remember. Then you can see that area from minus infinity to 0, please remember it is 0.5, it is fixed. Then phi of 2.43 student, I think, please tell me the answer now. You can calculate the values. I'll show you once again.
0.0075.
Yes, very good. You got the answer. Just put the value 2.43. So in the same settings, please write down the settings one side. It is 0.49245. I think everybody must get the same answer. So calculate 0.5 minus 0.4925 students. You can round up. So if you subtract the values, I think everybody must get 0.0075 students. So please write down these steps for the calculator. It's a shortcut method to calculate the standard normal distribution, students. So now we'll go to the next one, that is the fourth one. You can see the probability distribution is modulus of z is less than equal to 1.95. Means modulus means what? You are going to take the area from minus 1.95 to plus 1.95. That is the meaning of modulus. That is the mod of z. Means you are going to find the area from minus 1.95 to plus 1.94. Sorry. So this is equal to, actually you can do like this, area from 0 to minus 1.94 you can take, means minus 1.942 0 you can take. I will divide this like this. Similarly, plus I will take area from 0 to 1.94. That is probability area from 0 to 1.94 students. So like this you can divide this for 0 only. Because if you see the curve, that is our normal distribution curve, that is a bell shape, you can fix the mean 0, and I will fix 1.94 minus 1.94, and I will fix the area, that is 1.9 plus 1.94. This is our area. If you add this, you will get the probability modulus z less than equal to 1.94. You are going to get the probability of this area. So you can see this is equal to, you are going to add these areas. This is very clear. So this is equal to phi of 1.94. I'm going to calculate the value, and in the this side plus it is again phi of 1.94. Same areas, equal distributed. That is symmetric. So you can see 1.94. You can just calculate. So again I will show you mode 3 AC shift 1 5 2. So I'm going to get Q, that is 1.94 student. So I think everybody must get the value, that is 0.4739. You can see in the screen it is 0.473. I will round figure it as 8. So plus again it is 0.47838. If you add the values, you are going to get the value as 0.9476 students. So like this you should able to solve the examples. So we'll go to the next example, that is very simple example you can see on the screen students. That is, if x is normal distribution with mean 12 and a standard deviation 4, find the following probability. You can take this example, next example, and we'll solve the solution. Now you can see what they have given here student. They have given here mean and standard deviation. So means they have told you to calculate in terms of z, they have x they have given. Remember this is normal distribution they have given. We have to convert this in standard normal distribution. So I will take the value now. Let this is our standard normal distribution formula to convert this. So as you see, they have already given mean, that is mu is given 12, and sigma is given, that is standard deviation is given 4. So this is our mu and this is our sigma. And you can see they have given these values. You can see first one, this is a probability of x less than equal to greater than equal to 20. This is in terms of normal. We'll convert this in standard normal distribution. What I will do simultaneously, you can see here, very important, what I will do here, I have to convert this like this. So instead of here x, I will minus 12 I will do. Similarly, in the RHS side, I have to continue the same values, minus 12, both the sides, divided by, I want here 4. Again, I have to divide this by 4 on the both these sides. Yes, I can see. So this is equal to, I am going to convert this. This is equal to probability. You can see this function I have converted into standard normal distribution, that is z. So z is less than equal to, you can see this is 20 minus 12 divided by 4, means it is 8 divided by 4, which is equal to 2. So means we have converted this in standard normal distribution. So this is the value we are going to calculate. Now you can see, I will show you in the graph, it will be very clear. So this is our normal distribution curve, that is bell shaped curve. So it's gone outside. Okay, and I'll try to draw it neatly. Oh, fine. This is our mean. As you have to remember, this is 0. This is minus infinity. This side it is infinity. I will fix the area here. This is our 2. I'm going to take this as 2. means you are going to calculate the area greater than 2. Remember, if it is greater sign is not given means you are going to take this infinity. Please remember this. Again, you will be having confusion why which area you are going to calculate. This whole area, that is 2 to infinity. This is the area you are going to calculate. Therefore, means I am going to take the area from, it is clear, 2 to infinity. This area I want. So to instead of calculating this area, how we will simplify this? I will take first full 0 to infinity I will take, and I will divide this 0 to 2. This is what the simple idea you can do. That is probability area from 0 to infinity minus probability area from 0 to 2. You can do. Then you will get the area from 2 to infinity, students. So I think you should remember that when you take area from 0 to infinity, that is 0 to infinity, area you have to remember it is 0.5. So this is 0.5. Fix this minus phi of 2. So please can you tell me what is the value of phi of 2, students?
0.022.
Yes, very good. So you get the value, it is minus 0.22. Total answer this is?
Yes, sir, it is total answer.
Uh-huh.
0.0227.
Yes, very good. The answer is correct. Please tell me what is phi of 2 first.
0.4777.
It is 0.477. Very good.
0.477.
1,
No, sir. Correct it, sir.
okay, fine. So you can just simplify this. So you can, I think you will get the value as 0.022. Yes, I think this is the answer you have.
7.5.
7.5. Okay, you can go for 7.5. Fine. So this is the correct answer. You will get the probability of x greater than equal to 20, or if you convert this in standard normal distribution, this will be z greater than equal to 2. Please remember this. Then we'll go to the second one, student. What they have told you to calculate here, we can see here. What is the second you are going to calculate? That is probability of x less than equal to 20. Okay, start solving, student. Don't waste the time. It is probability of x less than equal to 20. Now again simplify this. Already I have calculated. Once again I will simplify this. So I want to convert this. So I'm going to take this as 12 divided by 4. That is our z. I think you remember this z now. Same way I will do here also. Minus I will do both the sides and divide both the sides by 4. So I'll convert this p of z less than equal to, this is 2. I think this is clear. So this is equal to. So now please tell me how you are going to calculate. Tell me the answer. That is probability of area. So this is again, if this limit is not given means you are going to take here infinity. Okay, so this is a probability of area from infinity to 2. So means how will be your normal distribution curve? Like this, infinity. This is your normal distribution curve, minus infinity to infinity. You can take this mean from, sorry, I'll try to do it straight. I'll try to draw a straight line. Okay, this is our straight line. So already you know this is our fixed 2 here, right? And I fix this 2, I want this area, sorry, less than means how it will be? Plus. Yes, sorry, correct, you are right. Minus infinity. This area I want, no, correct. So this full area I wanted to calculate. So I will divide this from minus infinity to 0 I will make, and then 0 to 2. So this probability I'm going to take here, area from minus infinity to 0. So this is minus infinity, sorry, plus, I will plus add this. So plus probability area from 0 to 2. Now I think you should remember from minus infinity to 0 it will plus, and this is phi of 2. Already you have calculated this. Phi of 2 is nothing but 0.477, means this is 0.5 plus 0.477. So therefore, if you just calculate this, I think you should get the answer here, student. It is 0.977. Yes,
0.7725.
very good, very good. Your answer is correct. I think you are now perfect in the calculator. Yes. So this value is nothing but there's a probability of x greater than or equal to 20, or if you convert this in standard normal form, it is going to, you are going to get here z, sorry, this is z, so this is less than equal to, okay, fine, fine. You're right. Last example was greater than equal to, this is less than equal to 20. So here you are going to get probability of z less than equal to 2, students. So this is what you get the answer. Yes, if you have still doubt, please ask me. Yes, any doubt, students? If you have no doubt, then we will conclude this class. Yes, thank you.